Greetings, pre-calculus students, to another day in our lesson in our unit, on trig and the unit circle. So we are going to continue our foray into graphing sine and cosine. So in our previous lesson, we talked about this idea of the amplitude and the period of a graph function, and more specifically, in our previous lesson, we were looking at individual graphs, and from there determining what is the amplitude of the graph, what is the period of the graph. So today we're going to start off by looking at a few function equations and determining from there the amplitude and period, and then we're actually going to get into more graphing of these functions given their equations. So first let's talk about how does amplitude and period affect trig equations? So how does amplitude and period affect trig equations? Well, given a and b are real numbers, then the equations y equals a times sine of bx and y equals a times cosine of bx. So we're given those equations. So a and b are just numbers. Describe trig graphs where a equals the amplitude. Okay, so that number in front of each respective trig equation is going to represent the amplitude of the graph. And remember, amplitude is half the height of the curve, And now the period, so this is where students will make a very common mistake here, okay? So most students will make the association, or they will remember that, that the number in front of the equation, that a value, is going to be the amplitude. And one quick comment about the amplitude. The amplitude is always positive, okay? It is always positive. Because sometimes you'll see values, or you'll see numbers in front of the equation that are negative. Even if they're negative, the amplitude is still positive, all right? So even if the value in front of the trig equation is negative, the amplitude is still a positive value. So let's say if it was -3 in front of sine, the amplitude would be +3. It would not be -3. All right, so back to this idea of period. So most students will remember about the a value being the amplitude, but then some students make the mistake of automatically assuming that the b value is the period. It is not. The number in front of x is not the period, not directly anyways. It's used to figure out what the period is, but it is not the period itself. So here you go. The period, on the other hand, of the graph is equal to 2 pi divided by b. 2 pi divided by b. So the period is always equal to 2 pi divided by whatever the number is in front of x, so the b value. Okay, so if the number in front of x was 2, your period would be 2 pi divided by 2. Okay, and remember the period is the horizontal distance that it takes the graph to complete one cycle. Just a quick review of that one. So amplitude, period. So that's how we determine the amplitude and period, just by looking at the equation. Let's look at a few examples. So example 1a, y is equal to 2 times sine of x. Y is equal to 2 times sine of x. All right. Well, remember, the a value is that constant in front of the trig equation, or the constant being multiplied to the trig function. So in this case, it's 2. And the b value, at least for this example, the b value is invisible, but it is there. Remember, whenever you have a variable all by its lonesome, there is a 1 in front of it. Now, typically we don't write the 1 because 1 times anything is just itself, but there is a b value, and that b value for this example would be 1, okay? Because there is a number in front of that variable. Even though it's not explicitly written there. Okay, so that means, just like we just talked about, that the amplitude is equal to a, so in this case it's equal to 2, simple enough, and the period is equal to 2 pi over b, so in this case it would be 2 pi over 1, so our period for this example is simply 2 pi. That's it. That's all you have to do. Okay? Once again, most students will remember the amplitude, but then they make that mistake about the period. Yeah, the period is 2 pi over b. 2 pi over b. All right. So now let's look at another example. Whoops, that I kind of wrote over. Fix that. So period was 2 pi over b. So 2 pi over 1, 2 pi. Now let's look at another example, a cosine one. Y is equal to cosine of 3x. Y is equal to cosine of 3x. Well, let's see. Once again, the a value is going to be whatever number is being multiplied in front of the equation. In this case, it would be 1, because it's not explicitly written there, so that means it's 1. But this time, our b value, it's not invisible, our b value, use a different color here, our b value is 3 this time. So that means our amplitude is equal to a, so it's equal to 1. And our period this time around is equal to 2 pi over the b value, so 2 pi over 3. And there isn't really much else you can do to simplify that. It's just 2 pi over 3. So that's it. That's all you have to do to figure out what the amplitude and period are for each function equation. Okay, these next two examples, C and D, I want you to do on your own. Okay, so these next two examples, C and D. So C and D on your own. Okay, so C and D I want you to try out on your own. So determine the amplitude and period for each of those. And don't forget for D what I just told you about those negative amplitudes in the previous slide. Okay, so that's it for determining amplitude and period given a trig equation. Now let's look at graphing. Okay, now let's look at graphing, which is more or less what this phase of the unit is mainly about. It's about this idea of being able to graph these sine and cosine functions. Well, up to this point, you've done two graphs. Okay, and both of them were on Desmos. You did a graph of sine of x and you did a graph of cosine of x. Well, let's look at graphs that are different. Let's look at graphs that have like different amplitudes, different periods, not just simple basic sine of x, cosine of x, all right? So to do that, I'm going to introduce you all to a strategy, okay? A strategy that can be very helpful when graphing these trig functions. And this strategy is dependent or relies on the fact that, as most of you have noticed, that the trig graphs just repeat, right? They go up, down, they go up, down, up, down. They just repeat the same pattern over and over again, okay? So that's what this strategy relies upon. The fact that our sine and cosine graphs are periodic, right? They just repeat the same period over and over, and you get a shape that, once again, just repeats a pattern. So the whole gist of this strategy is let's establish that pattern. Once we establish the pattern, right? Once we establish the pattern, we can just keep on repeating it over and over again. We don't have to keep on finding extra points because we can just repeat the points that we have already, and that makes up our graph. So the first step, okay, in using this strategy, the first step is you want to choose a starting point. Now the easiest would just be the y-intercept, okay? So the y-intercept, that would be the easiest way to go, which in this case would be when x equals 0, right? When x equals 0, what is the function equal to, all right? So the y-intercept. So that's typically a good starting point, okay, the y-intercept. And then from there, you use your starting point and the period to determine where one cycle ends, okay? So you use the starting point plus the period, and then that's going to be your end point, quote unquote, okay? So starting point plus period gives you where one cycle ends, right? Because that's how long one cycle takes, is one period. Whatever the period is, that's how long one cycle or one pattern of the curve to complete. And then you plot out basically the values in between. Okay, you plot out the values in between by using a table. So that's step 3. And then step 4, you just make a note of where the minimum and maximum values are of the function given the amplitude. Okay? So I call this the 5-point technique. The 5-point technique. Because as you'll see, as we're graphing these functions, for each of these functions, we're going to find 5 points. We're going to identify 5 points, and those 5 points are going to represent one period, or one cycle of the graph. And then from there, whether we want to go to the left or to the right, we're just going to repeat the same points because the graph is just going to keep on repeating after that one period. All right, so let's try out our first graph. So our first graph is y equals sine of pi over x. So y equals sine of pi over x. So remember what step 1 was. Okay, here we have our table. Remember what step 1 was. Step 1 was find the y-intercept, or choose a starting point, which typically the y-intercept is the most convenient. So remember, the y-intercept is when x is equal to 0. Okay, so when x is equal to 0 is our y-intercept. So we're going to plug in 0 into our function. So let's plug in 0 into our function. So sine of 0 to, whoops, messed that up. Sine of pi times 0, right? Pi times 0. So that is, I'm going to run out of room here. That is sine of 0, because pi times 0 is just 0. So now you just got to look it up on your unit circle. So 0 on your unit circle is going to be that point right at the beginning of the circle, 1, 0, and you look at the y value, so it's going to be 0. So our first point on our graph is going to be that 0, 0. So that was step 1. Now step 2 is we're going to use our starting point, which in this case is 0, and our period, okay, to determine our last point, quote unquote. All right? So let's do that. Well, what is the period? Well, let's see. The b value for this function looks to be pi, right, because that's the value in front of the x, looks to be pi. So our period is going to be 2 pi over that b value, so 2 pi over pi. So the pi's in this case will cancel out, and it looks like our period is 2. So that is going to be our final point on our table. That's going to be our final point on our table. Or in this case, it would be 0 plus 2, because since we started at 0, which once again is a convenient spot to start, and then where the period ends is at 2. So now we're going to plug in 2 into our function. Because that's our new y value. So this time I'm going to make sure I have enough space. So sine of pi times 2, so that is just 2 pi. Well, time to look up 2 pi on the unit circle. So 2 pi just ends up being the exact same place as 0 because it's one full circle. So 2 pi is going to have the same y value as the first point, which is 0. So we have our second point at 2, 0. So let's see. Now it depends how you want to label your axes for this one, but I'm going to label it as the middle. I'm going to label the middle as 2. Okay, I'm going to label the middle as 2. Okay, so we have a point at 2, 0. So x value 2, y value 0. Okay. So we found 2 points so far. Remember, this is called the 5-point technique, so we still have to find points in between. Okay, so we did step 1, which was our starting point, step 2, which was our finishing point. Step 3 is we're going to find the points in between. Okay, and we find the points in between by literally just finding the middle, right? So for example, what is the middle between 0 and 2? 1, right? The middle between 0 and 2 is just 1. So that means our next point is going to be 1. So let's plug in 1 into our sine function. So sine of pi times 1, so that's just sine of 1 pi. We got to look it up on our unit circle, pi. So pi is the left edge of the unit circle, so negative 1 comma 0. So the y value is still 0 though. So it looks like we have another point at 1 comma 0. 1 comma 0. Fix that. There we go. And then how are we going to find the other 2 points? Take the middle again. What's halfway between 0 and 1? 1/2, or 0.5. So now we're going to plug in 0.5 into our function. So sine of pi times 1/2. So that's the same thing as sine of pi over 2. So we look up pi over 2 in our unit circle. Okay, so it's at the top of our circle. So the y value there would be 1. So it looks like we have a point at 1/2, 1. So for this one, we'll make this 1. So now I'm labeling the y-axis. So that's -1, that's -2. You will, for some of these problems, and for some of the problems in which you will be doing them on your own, you will have to get in the habit of being able to label the axes appropriately. The axes won't be labeled for you, so you'll have to label them just like I did in this example, so you can appropriately express where each of the points go. So we have 1/2 comma 1. So 1/2 will be exactly between 0 and 1. So that's our 1/2. All right. And now let's do one more point. So between 1 and 2, what is it going to be between 1 and 2? 1.5, right? Or 1.5. So I'm going to put 1.5. We got to plug that in. So sine of pi times 1.5. Well, 1.5, you might be wondering where 1.5 is. 1.5 is the same thing as 3/2. So this is the same thing as 3 pi over 2 on our unit circle. 1.5 is the same thing as 3 over 2. So 3 pi over 2 on our unit circle. Okay, so that'd be at the bottom edge, all right? And then the y value would be -1 this time. So our last point, so our fifth and final point is going to be 1.5 comma -1. Now we can make our curve by connecting the points. So let me see if I can do a good drawing of this. So I got to go there, there. Okay, so that's what we have so far. We have that curve. Well, remember, that is one period, right? That is one period, which means once we plot these 5 points, we can just continue the cycle, people. So it went up, then down, then up again. So what does our graph need to go next? It needs to go up, then down, then up again. Right? Up, then down, then up again. If we wanted to go more to the left, we could do that too. So our graph would go down, then up, then down again. And then down, then up, then down again. Right? So there you go. Just by doing 5 points, we were able to graph a lot more periods, a lot more cycles of the graph. Right? Here's another cycle that we did. Here's another cycle that we did. And then here's a 4th cycle. So we did 4 cycles based upon just 5 points, though. Okay? Because once again, those 5 points are just going to repeat. Right? So we started at 0, then we went to 1, then 0 again, then -1, then 0, then 1 again, then 0, then -1, then 0. So you see there's a pattern. 0, 1, 0, negative 1, 0. Right? Or backwards, negative 1, 0, 1, 0, negative 1, 0, 1, 0. So there is a pattern to it once you get those original 5 points. And that's why this strategy can be very useful. Because once you have those points, you can just repeat them. Just repeat the y values, but you just have to keep on moving, obviously. All right. So now let's try a cosine one, and we're actually going to do, not this one, I think I wanted to do this one. Was it this one I wanted to do? Give me a second here. What is this cosine one? This cosine one is just that. Yeah, let's do this one. This cosine of 3x one. Let's do this one. So remember, first step, get that starting point. Okay, get that starting point for the curve. And we do that by just doing the the y-intercept. So just plug in 0 for x. So let's see. We have cosine of 3 times 0. So that's just cosine of 0. So we look up 0 degrees on the unit circle. And since cosine is the x value, you got to look at the x value for that point. So it's equal to 1. So our first point, and once again, I'm just going to label it the same way. Make this 1. So that's 2. That's negative 1, negative 2. So our first point is 0, 1. First point is 0, 1. Okay? Now let's do our last point. Well, our last point is determined by how long our period is. Well, let's see. Our b value is 3. Our b value is 3. So let's see. The period, once again, is 2 pi over b. So in this case, it would be 2 pi over 3. Okay, so this one's a little bit different. Our period this time ends at 2 pi over 3. So that is where our last point on our table will be, at 2 pi over 3. So let's plug it in, see what we get. So let's see, we get cosine of 3 times 2 pi over 3. So those 3's are going to cancel out. So we end up with cosine of 2 pi. So we look up 2 pi in our unit circle, and it ends up being the exact same place as 0. So cosine of 2 pi is going to be 1, because that's the x value at that point. So it looks like we have a point at 2 pi over 3, 1. So once again, I'm going to label 2 pi over 3 as the middle there. So then we have it at 1. So that's another point. So, all right. So now let's find the other points. And once again, the other points are going to be found by finding, okay, what's between 0 and 2 pi over 3? Okay, what's between 0 and 2 pi over 3? Well, the easiest way to do this is do some simple math here. What is 0 plus 2 pi over 3? Well, it's 2 pi over 3, right? Well, what happens if you divide that by 2? Actually, you know what? Let me do this over here because I have space. Okay, so let's see. So 0 plus 2 pi over 3. That's just 2 pi over 3. What happens if I divide it by 2? Because we're trying to find the middle, or halfway between those two. Well, if I divide it by 2, that's the same thing as multiplying it by 1/2. So I end up with 2 pi over 6. And 2 over 6 can be simplified to 1 pi over 3. So that's going to be our next x value. 1 pi over 3. Because that's halfway between 0 and 2 pi over 3. So let's plug that into cosine. So cosine 3 times pi over 3. Once again, the 3's cancel out. So we end up with cosine of pi. Let's see, cosine of pi in the unit circle. Okay, so it's going to be on the left edge there. And the x value would be negative 1 this time around. So at pi over 3, we have a point at -1. All right. Okay, what about between 0 and pi over 3? What about between 0 and pi over 3? Well, let's see. So we have 0 plus pi over 3. So that's just pi over 3. And then we have pi over 3 divided by 2, which is the same thing as pi over 3 times 1/2. So halfway between those two would be pi over 6. So that would be our next x value, pi over 6. So we have cosine of 3 times pi over 6. So that gives us cosine of 3 pi over 6. And 3 pi over 6 is the same thing as pi over 2, because 3 over 6 is just 1 over 2. So pi over 2 is what we have. So we have pi over 2. All right. So pi over 2 on the unit circle. Okay, so it'd be at the top edge. And we're looking at the x value since it's cosine. So it'd be 0. So at pi over 6, we have a point at 0. And then finally, this one might be a little bit trickier. We have to find halfway between pi over 3 and 2 pi over 3. So I'm going to do it over here. So pi over 3 plus 2 pi over 3. So that gives me 3 pi over 3, which is just pi. And if we divide pi by 2, well, then you just get pi over 2. Simple enough. So pi over 2 would be halfway between pi over 3 and 2 pi over 3. All right. So now we do cosine of 3 times pi over 2. So it's cosine of 3 pi over 2. So now we just got to look up 3 pi over 2 on the unit circle. Okay, so it's down there. We've got the x value, so it'd be 0. So at pi over 2, we end up with 0. So we got our curve. We have our curve. That goes there, goes there. All right. And once again, remember, this is one cycle. This is one cycle. So now we can just repeat it. We can just repeat it. So it started high, then it went down, then it went high. So it started at a maximum, right, the high point, and then a minimum, the low point, and then back to a maximum. So we just got to repeat. So 1, 0, -1, 0, 1, 0, -1, 0, 1. So there's another cycle. Or if we wanted to go in the other direction, it'd be 0, -1, 0, 1. And then 0, -1, 0, 1. So it just repeats, right? You just keep on going. 0, 1, 0, -1, 0, 1, 0, -1. So you just keep on going. Just keep on going. Just repeat that pattern as far as the graph can take you. Oh, man, that was a little bit messy. My finger slipped there. Yeah, so there you go. Right? So that's one cycle. That's another cycle. It's another cycle. And remember, each cycle is exactly the same, right? Goes up, down, right? And there we have our graph for cosine of 3x. Okay. So you know what's next. These next two examples, you will be trying it out on your own. So, went the wrong direction. So here's one of them. So example 2c. So y equals 2 sine of the quantity pi over 2 times x. And then y equals negative cosine of 2x. Okay? But once again, you're just repeating that 5-point technique, right? You find the y-intercept, you find the period, so you can find what your quote-unquote final point is, and then you find the points in between by just plugging everything into the equation by using the table. Okay, so once again, part C on your own and part D on your own. Just repeat it. Obviously, you can always use Desmos to make sure that your graph is turning out how it should be, just to make sure, especially with your values, for example. Yeah, don't forget, Desmos is always a tool that you can use to make sure that all your points are where they should be. Otherwise, that is it for today. Okay, so you have 4 on your own problems to do, 2 graphs, and then 2 of those equations where you determine the amplitude and period. Otherwise, as usual, let me know if anything does turn out to be super confusing. Leave me a comment in the classroom. Do whatever you need to do to reach out to me. But otherwise, I hope this lesson went smoothly. Hope you guys stay safe. Enjoy the rest of your day.